Okay, so trigonometry is about the measurement of triangles. So what does it allow us to do? It allows us in a right angle triangle to, if we know one of the other angles apart from the 90 degrees, say this angle, or if we know this angle, and we know the length of one of any of the sides, trigonometry allows us to work out the lengths of all the other sides and the other angles. So to solve a problem in trigonometry, we first need to put labels on the sides of the triangle, and the labels are put on depending on what or which angle it is that we know. So for example, if we know this angle, we put on labels the hypotenuse onto the longest side. The opposite will be the side that is opposite the angle, and the adjacent, you could either say it's the other side that's left, or you could say it's the one beside the angle. Just to show that these labels are dependent on whichever is the known angle. If we move the known angle, if we had known this one, then this becomes the adjacent and this becomes the opposite, and because the hypotenuse is always on the longest side, it stays the same. So to get started on solving a problem, we have to understand three trigonometric functions. They are the sine, the cosine, and the tangent. The sine is the ratio of the opposite to the hypotenuse. So it means the ratio of what? What it means is if you had the length of the hypotenuse and you divide it by the the length of the opposite, and you divide it by the length of the hypotenuse, the number that you get is the sine of that angle. If we look at the cosine, it's the ratio of the length of the adjacent divided by the length of the hypotenuse, and the tangent is the ratio of the opposite versus the adjacent. To help you remember these, there's a mnemonic that you might have already come across. SOHCAHTOA. So is sine is opposite over hypotenuse. Ka is cosine, adjacent over hypotenuse, and TOA is tangent, opposite over adjacent. So if we look at a problem, this one is from the exercise. It'll help you understand it better. So we have here a triangle, and we need to have one angle that's known other than the 90 degrees, and we do. We have this angle here of 41 degrees. We also need to have one side that we know the length of to make it work, and we do. The opposite side here is 6 centimeters. So that means we have enough to work out the lengths of the other sides as well as the angles. So the problem in your book is, what is the length of A? So we see here we've got three things we could use: sine, cosine, or tangent. So which of those three do we use? Well, we want to use something that, so the side we want to know the length of is the adjacent. So we want something that will deal with the adjacent in the function. So if we look at sine, first of all, the ratio of the opposite to hypotenuse, it doesn't even deal with the adjacent. So I think we could just eliminate that right away. We're not going to use that. If we look at the other two, are we going to use the cosine or the tangent? Well, the cosine allows us to take the adjacent in with the hypotenuse, but we don't know the value of the hypotenuse, so that's not going to be much use to us. So it leaves us with the tangent, and lucky enough, it has the adjacent and also the opposite, which we know. So always look for something that is, if the side is the adjacent, make sure the adjacent is in the function, and that the other value, the other side, you have to actually have a value for it. So we're going to use tangent, and as you know, the tangent is the opposite of the adjacent. So we put that in. Now we're going to work this out. What we're actually looking to find is the adjacent. So we really want to rearrange that formula so it's better placed to give us that. So if we remind ourselves of the formula triangle that would be appropriate for this, we find out the adjacent equals the opposite over the tangent. So we put that in. Notice the tangent, when we talk about it, it's the tangent of 41 degrees. So we now know that the adjacent equals the opposite divided by the tangent of 41 degrees. How do we know the tangent of 41 degrees? We just hit tan on our calculator and type in 41 and equals, and it will give you that value. We know what the opposite is. The opposite is 6, and if we put that in, so we have 6, and this is the tangent here, 0.869 is the tangent of the angle 41, and that will work out at 6.9 centimeters. So that was, using the tangent. Using the sine and the cosine is just the same, and the reason we would have used those is because they would have had the correct sides associated with what we wanted to find out. So remember to look at what you know in your triangle, what side value you have, and see which fits your requirements best, the sine, the cosine, or the tangent. I hope that was of some help for you.